A little kid is flying a kite. The string of the kite makes an angle of 30 degrees with the ground. If the height of the kite is 12 meters, find the length of the string to the nearest tenth of a meter. So here we're given a bit of information. First off, we're given an angle of 30 degrees, and this 30 degrees is produced or generated when the string of the kite basically interacts or basically meets with the ground. All right. And then we're also given a length of 12 meters. Now, this 12 meters is the height, I should say, sorry, not the length, but the height of the kite. Okay, cool. So let's actually try to build a diagram to see what's going on. All right. So I'm going to start off with building a two lines. All right. And what these two lines signify is two different things. So this signifies the ground, right? So this is our ground. All right. And the reason why it's our ground is because you can see it's the lowest point of anything else in this diagram. Nothing will be lower than the ground. All right. Now, what interacts or meets with the ground? Well, if we read the wording of this question, the string of a kite makes an angle of 30 degrees with the ground. So therefore, this bit over here has to be the string of the kite. All right, and that is really hard to see. Let me just write that again. All right, so that's your string. Cool. So now what it says is that the height of the kite, so we can just close that off there, right? And just disregard this bit. But when we close this off, right, what do you think this would signify? This length over here. Remember, this is the string of the kite. I'll kind of draw that to kind of show the kite, right? So that's your kind of kite. And then this is like your string, right? So what would this signify then? So if this is the kite, right, what would this length signify? That would signify the height, right? Because it's showing us how high up the kite is over here based off of the ground or the surface level. Okay? And what was that information? Well, that information we got to be 12 meters. Okay? 12 meters. So, cool. We got this first information done, right? We added that information into our diagram and we could kind of start doing things. But before we do anything else, there's one piece of information that was given in the a question, right? That we still haven't integrated into our diagram. Because remember, the diagram is the tool that we're going to use to solve our problem. And that is the 30 degrees. So where would the 30 degrees go? Well, it would go right here. So I'm going to just use red. So that is 30, 30. I'm going to just change the width. Oops. Okay, we are at the lowest. That's my bad. So that is 30 degrees. Okay? Cool. So now we have the both of the information that we were given, they are used up. All right? And this is the diagram that we get back. Remember, the string of the kite is this, the height is this, and the ground itself is this. So what is the question asking us? It's asking us to find the length. So the measurement of the string itself. So what is the string again? Well, if you haven't guessed already, it would be this portion here, right? Because that's exactly what we said when we were building our diagram. This is why visualizing it by building a diagram like this makes things so much easier. Because first of all, you'll see that this is a triangle, makes a right triangle, right? With this being our right angle. But then we also figure out which length is the strain, and what would represent the basically the measurement for the strain. Okay, cool. So now what we can do is we can actually use different trigonomic functions to figure out the length of strain. So currently we have these two bits of information. And what do they represent? Well, the 30 degrees, would represent our theta for our trigonomic function. But even more than that, it's our angle of reference. Okay, so that is our angle of reference. So we observe everything from this angle over here. Okay, now what does this 12 meter tell us? What length is it? So you can either have a hypotenuse, an opposite, or an adjacent. So we have to use the theta angle or the angle of reference, which is 30 degrees, and we have to basically look from there to try to find the 12 meter, right? And then based off of the positioning, it would signify a different type of length. So for an opposite length, it would just be whatever is the opposite of that 30 degrees. So that would be 12, right? Because that is the opposite side of that 30 degrees. So we already know automatically that this is opposite. Now, on the off chance that it wasn't opposite, for adjacent, it would be the line that the angle resides on, right? So it would be the ground. The ground would be the adjacent. And then hypotenuse is the largest side in the right triangle, which is the string. This actually tells us another piece of information. And it tells us that the string value that we're trying to find is in reality just the hypotenuse of this right triangle that we constructed. All right? Okay, cool. So now we have two different lengths. We have the opposite length and the hypotenuse length. Cool. So now, based off of SOHCAHTOA, so SOHCAHTOA, we got to figure out which one of the ratios we will use to figure out the hypotenuse, right? Because the golden rule in trigonometry is that you need three things. You need two different side lengths, right? And then you need one angle. And we have that. We have the side length of the hypotenuse, which is unknown, it's x, right? We also have the 12 meter, which is the opposite length. So we have two lengths. And then we also have angle theta, which is 30 degrees. And from this three information, we only need two of them to be known. And one can be unknown. So we can just kind of use algebra and different methods like that to figure it out. So we have all of that, right? So now let's go ahead and figure out the ratio that we have to use. And that's based off of the two types of lengths available to us, which is opposite and hypotenuse. And that would be sine. Because what this is really saying is it's saying the S signifies sine, right? The actual trigonomic function. The O represents opposite. So that's our opposite length, which is 12 meters for us. It's 12 meters for us. And then the H represents the hypotenuse. The hypotenuse. And the hypotenuse is going to be x. All right. So that's how we got that sine, or we got to the conclusion that this is the sine value. Okay. So what we're going to do now is we're going to do our mathematics work here. So I'm going to say sine, right? Sine theta equals, and then what is sine theta equal to? Well, this is saying sine and then an unknown angle, because theta represents an angle. And remember, sine is just a ratio from opposite and hypotenuse. So let's just go ahead and build on that ratio. So we get opposite and hypotenuse. Cool. All right, so now we have sine. And then angle theta, we already know what that is in our case, which is 30. So let's add that. 30 degrees, and then that's going to equal, and then let's substitute in whatever we know for opposite and hypotenuse. So for hypotenuse, it's going to be not HYP, but X, because that's what we've assigned the unknown value to. And then the opposite is going to be 12. Now in your calculators, we're going to go ahead and figure out what the sine of 30 degrees is. All right, so you want to make sure that your calculator is configured to use degrees, not radians, right? Because that's a different unit of measurement. And when you do that sine of 30, um, this is like one of like the benchmark of sines that you should know, is it will just give you half, right? And so that's going to equal 12 over x. Okay. Now, you could keep it in the fraction form and then you could do cross multiplication to figure it out. But you're not always going to have it in a fraction form for sine. Sometimes you'll just get like a decimal number. So let's just use a decimal number to simulate that. So let's say 0.5, right? So sine is 0.5, which is just one half, right? And so that equals 12 over x. Okay? So in this case, what you would do is you just add a 1 over it. All right? And then you do your cross multiplication. But since the 0.5 can be simplified to a fraction, it would just be better to have it in fraction form. Okay? All right, now what we do is cross multiplication, and we do cross multiplication to figure out the unknown value of x. So we would multiply 2 and 12 together, and then 1 and x. 1 and x together. Okay? And what that gives us back is x, which is going to equate to 2 times 12. Because remember, 1 times x just produces the same result. And so then x is going to equal 24. Because remember, 2 times 12 is what? It is 24. Okay? So in the end of doing all of these calculations, we have figured out, excuse me, that the length for the string is going to be 24, but not 24 only, it's going to be 24 meters. So we can write a concluding statement as so. Therefore, right, this is the therefore sign, string equals 24 meters long. And that is a wrap.